When Russian glide bombs started raining down on Ukrainian cities in 2023, they seemed unstoppable. These satellite-guided weapons could strike targets from dozens of miles away, keeping Russian aircraft safely beyond the reach of most Ukrainian air defenses. For months, these weapons wreaked havoc across the front lines, forcing Ukraine to scramble for countermeasures. Russia started increasingly relying on these systems to overload Ukraine's defense systems, using the quantity over quality paradigm to constantly pressure the smaller army. However, these and their related system from the US, the Joint Direct Attack Munition or JDAM, Precision Guided Package Add-on, have never truly gotten to the cutting edge of modern technology. Even so, America wasn't just watching this technological demonstration of dumb bombs made smart, it was taking notes. And the next US-created defense system on the radar could upend the entire structure of modern long-range warfare. Enter the StormBreaker bomb. This is a weapon so advanced that it doesn't just hit targets, it hunts them. With artificial intelligence, real-time target tracking, and the ability to operate in conditions that would render traditional weapons useless, the StormBreaker represents a quantum leap in precision strikes that should make all US enemies afraid of being next on the radar. This isn't just another smart bomb. It's a one-size-fits-most weapon that solves every major limitation plaguing current-generation weapons while introducing capabilities that seemed like science fiction just a few years ago. So let's dive into what makes the StormBreaker missile so terrifying and how it can become the pinnacle of standoff warfare. To understand the possibilities of the future, we need to analyze exactly what makes current systems as effective as they are, and how they have changed the flow of the war in Ukraine. The reason for glide bombs' sudden appearance in the skies above Ukraine is due to convenience. Namely, when Russia realized that expensive systems were not delivering the results worthy of their cost, it turned to its Soviet roots to integrate old technology in new ways. This led to Russian forces deploying UMPK, or Unified Gliding and Correction Module, in Russian systems to convert Cold War-era gravity bombs into satellite-guided weapons. The base of the bomb is the simple Fab 500, which carries 440 pounds of explosives, or 500 kilograms as its name suggests. Russia has also used the bomb's cousins from the slimline Fab 250 to lower the bomb's mass as much as possible in an attempt to increase range, up to the devastating Fab 3000 to potentially devastate entire city blocks and military installations. All the UMPK does is add a simple aerodynamic system to allow the bomb to glide through the air rather than fall in a basic parabolic trajectory, while an integrated inertial guidance system allows for small course corrections. In any case, the bomb remains free of self-propulsion, which makes it less detectable for modern heat-tracked interception systems. On the other side of the conflict are JDAMs, guidance kits that bolt onto unguided bombs to transform them into precision weapons. The kit adds aerodynamic strakes, a tail section with control surfaces, and a GPS-enabled guidance system, allowing the modified bomb to strike targets with high accuracy. These upgrades mean a traditional gravity bomb, once limited to free-fall deployment from bombers, can now be launched from fighter jets and other aircraft, greatly extending its tactical flexibility and usable lifespan. JDAM-equipped bombs are formally designated as guided bomb units, or GBUs, like the GBU-31, which combines a JDAM kit with a 2,000-pound BLU-109 or MK-84. While these bombs are designed to glide to their targets from extended ranges, they are not equipped with loitering capabilities. Their control surfaces enable mid-course adjustments, but their primary purpose is to deliver a precise, direct strike, not to circle or wait over a battlefield. These weapons have proven devastatingly effective against static targets. UMPK-equipped bombs can reach targets up to 60 miles away. These weapons have proven devastatingly effective against static targets. UMPK-equipped bombs can reach targets up to 60 miles away, allowing aircraft to launch from relative safety. Ukraine has responded with its own arsenal of American and Australian-sourced JDAM-ERs and GBU-39 small-diameter bombs, which usually have similar ranges and effectiveness. This has created an unenviable position where the side with more weapons or more capable defensive systems wins. Currently, that is slightly in Russia's favor, as Soviet-era fabs don't seem to be running out in any reasonable measure, and Ukraine is at the mercy of NATO for procurement, which is on a significant delay compared to its domestic production capabilities of drones, and is its main way of overcoming the numerical disadvantage. However, despite their battlefield success and widespread use in the war in Ukraine, current-generation glide bombs suffer from limitations that make them increasingly obsolete against more sophisticated tactics and technologically advanced militaries such as the US or China. First, there's the range problem. Even extended-range glide bombs like the JDAM-ER require aircraft to fly to within around 45 miles of their targets, depending on the exact model of the bomb being used for the conversion kit. Against enemies with advanced air defense systems like Russia's S-400 or China's HQ-9, this puts deploying aircraft directly in harm's way. Modern surface-to-air missile systems can engage targets well beyond 60 miles, meaning glide bomb attacks become suicide missions against peer adversaries. Additionally, modern radars have detection ranges that measure in hundreds of miles. If they are positioned sufficiently close to the front line, they will be able to detect incoming aircraft before they can get a chance to deploy their weapons, which puts them at risk of being intercepted. More critically, most of these weapons are essentially blind once released. Relying on GPS-assisted inertial guidance, they strike only the predetermined coordinates fed to them before launch. If a tank moves 50 feet after the bomb is dropped, the strike will miss entirely, hitting empty ground while the target escapes. This is further complicated by the vastly different accuracy rates that the bomb can possess. In general, the circular error probable improves over time, with modern bombs having them at sub-30 feet ranges. This means that a bomb will hit a circle of 30 feet around its intended target half the time. However, old converted bombs might have a circular error probable of 100 feet or more. While Russia has reportedly improved the circular error probable of some of its systems from 160 to 16 feet, there's no telling if that actually improves the hit rate. If the hits suddenly become more concentrated, then a guided bomb that doesn't track its target might even get worse, as a less accurate one might hit due to veering off course naturally. This limitation has become increasingly problematic as modern warfare emphasizes mobility. Artillery systems now shoot and scoot within minutes of firing their shots, never staying in one place for long enough to risk getting counterattacked. Mobile air defense platforms relocate instantly. Even command posts and supply depots are designed for rapid displacement capabilities. When most of the targets can move in real time, the failure of glide bombs to accommodate them leaves them as only slightly more useful than traditional gravity bombs. And the alternative long-range precision missiles have different but equally serious problems. Heavy penetration weapons like the AGM-158 can only be carried by large aircraft in limited quantities. An F-35, America's premier stealth fighter, can't carry Joint Air-to-Surface Standoff missiles, JASSMs, internally, meaning it sacrifices its stealth profile if it carries them at all. This makes the missiles more valuable and larger strike teams much easier to detect. The StormBreaker is designed to overcome these obstacles and future-proof against potential advancements for years to come. The StormBreaker's first game-changing capability lies in its tri-mode seeker system that makes previous guidance methods look primitive by comparison. Traditional glide bombs use GPS coordinates similarly to a street address, but they also have the accuracy that could be feasibly measured in buildings. The StormBreaker combines millimeter-wave radar, infrared imaging, and semi-active laser guidance into a single integrated targeting system powered by onboard artificial intelligence. This isn't just redundancy for the sake of reliability. Each sensor feeds data to the others, creating a three-dimensional understanding of the target area that adapts in real time. The millimeter-wave radar can track moving vehicles through smoke and dust. The infrared sensor identifies heat signatures and vehicle types. The laser seeker provides terminal precision guidance. Unifying these systems is the potential to leverage AI for military tactics and real-time tracking. The AI doesn't just process the data and forward it to the deployment platform. It draws on thousands of simulated combat scenarios and test data to help prioritize targets, distinguish between decoys and genuine threats, and adapt to countermeasures in flight. According to Raytheon testing data, this integrated approach has achieved a 100% success rate in recent trials with F-35 fighter jets. This is an unprecedented level of accuracy, but it remains to be seen how it translates to real-life scenarios. Remember, even with Russia improving its precision strike capabilities with its own glide bombs, Ukraine routinely manages either to shoot them down or disable them electronically. This has led to Russia needing up to 16 bombs for each actual hit, reducing the success rate to a miserable 6%. This could be overcome with more improvements in the tracking system, such as a two-way data link between the missile and the deployment aircraft. With this, the missile can forward flight and navigational data to the jet and receive updated coordinates from a larger system. The onboard computer can then make subtle changes to the missile's flight path to alter its trajectory or even retarget it entirely. This ties into StormBreaker's ability to hunt moving targets with unprecedented precision. Previous smart bombs were essentially very accurate artillery shells. You point them at coordinates and hope the target stays put. But these two systems combined allow the StormBreaker to actively track, identify, and pursue targets throughout its entire flight path. This capability operates at ranges of up to 45 miles for moving targets, which matches the effective ranges of JDAM and UMPK bombs for stationary ones. Furthermore, the increased aerodynamics and improved targeting mean that the StormBreaker is designed to effectively engage stationary targets at around 70 miles away. This creates a more versatile solution that allows US fighter jets to leverage real-time data and stay out of enemy radar for longer when engaging stationary targets. Additionally, it precludes them from using air-to-ground missiles for mobile targets, which are generally much more expensive to procure and field. Essentially, the StormBreaker combines the capabilities of two distinct weapons systems into one, simplifying target acquisition and tactics for the US forces. Furthermore, the added range for stationary target positions allows American aircraft to be well outside the engagement envelope of most surface-to-air missile systems, while still allowing multiple weapons per sortie. An F-15E Strike Eagle can carry 28 StormBreakers simultaneously, thanks to the suspension units allowing it to stow 4 bombs per hardpoint. This can allow an older aircraft to engage more targets in a single mission than entire squadrons could attack using traditional heavy missiles. The extended range also provides crucial tactical flexibility. Aircraft can launch weapons and immediately turn away from defended airspace, minimizing exposure time to enemy air defenses. Multiple aircraft can converge weapons on target areas from different directions, overwhelming defensive systems through sheer volume. For stealth aircraft, the added range also allows them to maintain their low observable profiles while still engaging targets deep in contested airspace. This would be impossible with shorter range weapons that require closer approaches. Given that the US is close to rolling out a next-generation stealth jet, the recently unveiled F-47, the ability to stay hidden yet deadly will become increasingly important as airspace becomes more congested and observed. Then there's the psychological impact this weapon can create on the enemy. Previously, one way to blunt the effectiveness of glide bombs was to frequently reposition air defense systems after each intercept, avoiding retaliation by never staying in one place for too long. But mobile air defense or crews now face a weapon that can hunt them down regardless of evasive maneuvers. And there's another aspect that clues in on why this bomb is named StormBreaker in the first place: weather independence. Weather has been the Achilles heel of precision weapons since their inception. Laser-guided bombs become useless in clouds or rain simply by virtue of the targeting system. The laser reticle from the deployment aircraft can't penetrate dirt particles and gets deflected off clouds, vapor, and debris. Even GPS-guided weapons can be thrown off course by atmospheric interference. The StormBreaker's integrated sensor suite eliminates weather as a limiting factor entirely. The millimeter-wave radar operates effectively in conditions that would ground other precision weapons. Storm clouds, sandstorms, and even man-made smoke screens won't be able to deter a weapon that sees through multiple spectrums simultaneously. More importantly, since the missile is designed to be integrated with broader information-gathering systems, it can gather tracking data from multiple vectors and possibly even perform in-flight corrections on a smaller scale through its onboard computer. In fact, the all-weather operation is one of the key hallmarks of Raytheon's testing remarks. According to the company's press release, the weapon can operate in adverse weather conditions through its tri-mode seeker that employs infrared and millimeter-wave radar to see through fog, smoke, and rain. But beyond its operational capabilities, the StormBreaker presents a leap in weapon access to its small frame. At just 69 inches long and weighing only 204 pounds, it's specifically designed to maximize the current and future capabilities of America's stealth fighter fleet. More notably, the exact goal of the weapon is to at least quadruple the total carrying and engagement capacity compared to existing 1,000 and 2,000 pound missiles. As such, an F-35 can carry 8 StormBreakers internally alongside 2 AIM-120 AMRAAM, all while maintaining its radar-evading profile, which transforms the Lightning II from a limited payload stealth platform into a multi-target and multi-domain engagement system. If stealth is not an issue, the F-35 can mount an additional 16 StormBreakers on its external hardpoints, bringing its total capacity to 24 precision-guided weapons. This capability to carry enormous weapons payloads extends into early jet models too. The F-15E Strike Eagle can use suspension units to carry 28 weapons, while the F-22 Raptor can carry 8 missiles in its internal bays, switching from its air superiority focus to one of standoff engagement. Recent procurement data reveals the scale of American commitment to this capability. The Pentagon's 2022 report suggests that existing procurement options go to between 12,000 and 21,600 units for the Air Force and another 5,000 units for the Navy. It's unclear how many of these weapons have already been delivered, but a 2024 report suggests a new order for at least 1,500 weapons, following the orders from 2015 to 2023 that totaled 2,600 units. To top all this off, the actual cost of the missile is expected to be relatively tame. At between $70,000 and $200,000 per unit, the StormBreaker costs roughly the same as a Hellfire missile, while offering 7 to 10 times the range and significantly greater destructive capability. This makes it much costlier than JDAM and Russian glide bombs for stationary targets. However, you have to account for the added flexibility and the increased payload options. The StormBreaker is promoted as a weapon with 4 different operational modes, which make it as close to a universal precision weapon as possible. Coordinate Attack Mode functions like traditional glide bombs for pre-planned strikes against known static targets. Normal Attack Mode enables engagement of stationary or moving targets in any weather using sensor fusion. Immediate Attack Mode allows the weapon to hunt for targets of opportunity along a flight path. Laser Illuminated Attack Mode provides traditional laser-guided precision when ground troops or aircraft designate targets. Strategically, this allows the US unparalleled levels of battle readiness and preparation. American forces can respond to changing tactical situations without returning to base for different ordnance. A single sortie can engage mobile SAMs, static bunkers, and targets of opportunity using the same weapon system. But beyond that, it simplifies future weapons procurement. If the StormBreaker ends up being as effective as other weapons in a similar operational range, it allows the US military-industrial complex to retire old systems and refocus its efforts on creating a large arsenal of future-proof, multi-use missiles. This can redistribute funding that would ordinarily go to maintenance or retrofitting to production and storage. For enemy air defense commanders, the StormBreaker represents an entirely new threat axis. Traditional tactics of combining mobility and concealment to counter single-function weapons become useless against one that actively hunts through any conditions. At the same time, electronic warfare becomes more difficult to implement when the system is built with layers of redundancy, all the while utilizing one of the most advanced intelligence structures in the world. The weapon's AI-driven targeting means that even sophisticated decoys and countermeasures might not be a problem for the missile. Most terrifyingly for adversaries, the sheer volume potential means that defensive systems can be easily overwhelmed. A 4-ship formation of F-15Es can deploy 112 StormBreakers, which is more than some countries have missiles in their entire inventories. And current testing data suggests the StormBreaker may even exceed its impressive design specifications. The 100% success rate achieved in recent F-35 trials indicates a level of reliability unprecedented in precision weapons. Furthermore, Raytheon simultaneously testing the weapon on more platforms means that it's fully committed to optimizing it for all major US systems. Coincidentally, this can also extend to the rest of NATO, as the entire alliance has been building aircraft with the precise goal of being able to retrofit and reuse each other's arsenals when needed. Furthermore, StormBreakers might not be limited to jets either. Ground-launched and powered variants have been teased to be in testing. These options would allow the missile to be utilized instead of or alongside traditional mid-range precision strike weapons like HIMARS, when you need to strike a moving target in a shorter range. It can also create a development loop where adding propulsion to a bomb could lead to a more efficient air-deployed model. When combined with an aircraft's enhanced operational range, this could bring the missile to true long-range operations, completely avoiding the problems that glide bombs are attempting to bypass. And next-generation platforms like the B-21 Raider or F-47 could create strike capabilities that render entire categories of enemy targets vulnerable from unprecedented ranges. For America's adversaries, the StormBreaker represents a technological capability gap that may prove impossible to close. The weapon combines advanced materials science, cutting-edge electronics, sophisticated targeting systems, and precision manufacturing that is not something that can be built from the ground up in a decade. When American stealth fighters begin deploying these weapons in large enough quantities and across branches, enemy forces will face a simple reality: nowhere is safe. Thank you for watching, and to learn how the US deals with bunkers, watch our video on bunker-busting strikes against Iran. And to stay updated on the latest developments in military technology that are reshaping the future of warfare, subscribe to The Military Show.